choice. Oh, okay.
So, am I correct to remember you're running in office on draft producers that?
Yeah. You stopped off. I don't blame you.
I stopped it because Fernando said it was process violation.
Yeah, on software, we actually was on this. But I didn't really.
I wish that, and I would like, I want to stop it being officer and because he said that, so it's fine. But one way that we actually, so that checks will do.
So we put a text into it to clarify, some of the points, and it was an issue. So we clarified it, and now it seems to be ready to actually conflict. I'm happy to remove. I want to move onwards. I'll do whatever,
I approved it for and then 3 hours later, so
no, we were trying to Can we actually, I have an issue. We need to start actually. So I'm trying to figure out how to get the screen. Okay. No, but it's not a full screen thing. You see? So it's going into slide. They don't go into slide mode. I think I know. I'm gonna do it. I'm gonna make it a bit smaller.
yeah, that'll work.
And then we do.
It's not ideal.
I normally do Control L, and it goes into slide mode.
I should do it from my.
You want to try that again?
I would start an game.
We can do it.
So we are looking for a scribe and a minute taker. Any volunteer? Scribe, it's a nice name. Minute taker, it's also a nice job. This is when I see all the fields going down on the laptop.
Yeah, would be nice. Okay, thank you. I'll do it this way. This one is working perfectly. It's just yours which is very strange. It's just yours which is very strange. It's just the one you created.
So Ron Bonica was nice enough to be the minute taker with some delay, something like a couple of hours of delay. He will do it from the recording, but that's very good. Now we need the Jabber scribe. It's very easy, right? Simply say, who is talking? No Jabber scribe? Okay, thank you, Ron. So let's start this OPSEC working group meeting at the IETF 100. What we will do, Gunther van der Veld, I'm Eric Vink. Different information here. You can go to the next slide. The Note 12, that's the first day, and the Note 12 has been changed a couple of IETF ago, so you may want to read it when you have time, but it's basically whatever you say here is public. Again, it's the first day, so please circulate the blue sheets. As you may probably know, it's simply to size the room for the next IETF. So that's important. Agenda bashing. So this is the agenda that has been on the web as well. So Gunther and I will do some trivia, quick because there's not so much activities on this working group. There are 2 documents, and we shall spend 5 minutes on each that are working group documents. The one for Fernando about EH filtering that went into working group last call and was kind of back to the bench. and this one that takes forever, OPSEC V6 with Mary Kay, KK, and myself. We make a status over there. And then we start, as we done a couple of OPSEC meetings ago, to have working group, to have other documents that do not belong all the time to OPSEC, but they have an operational and security aspect, and they are put into different groups. So it's nice for those authors to come into OPSEC to get feedback or reviews from people having both an operational and a security background. So we have there a 5 paper. That's the agenda. Nobody want to change it? Okay, so let's go. Mr. Revia, very quick, as I said, Fernando's draft on OPSEC IPv6 extension and header filtering when there's working group last call in September, and he's coming back, and Fernando will explain what he will be changing. It was minor changes, in my opinion, so it could be easy. OPSEC, the document OPSEC is a version 12 now. It went on April in the working group last call, and it come back with many, many comments, which is pretty good. So we need to improve it. And there are 2 active individual documents, one on ICMP ingress filtering from Fernando, and another one from Sriram about OPSEC unicast IPF improvement, and it will be presented if we have time at the end of this session. So, Fernando, if you are here, I think that's the next one, right? Fernando just arrived, so he's running. It's up to you.
Good afternoon. Okay, I'm going to give you a heads up of the updates to the document recommendations on the filtering of IPv6 packets containing IPv6 extension headers. Next one. So, as an overview of this document, just if you never saw this document before, it's an IPv6 version of RFC 7126 that describes the interoperability and security implications of different extension headers and options, and provides operational advice on how to filter those packets on at transit routers. Next one. So these are the changes since the last version, not many. Essentially, one of the things that this IDE had, it had references to RFC 2460. So that was updated. That meant, for example, that there were places in which the document was talking about behaviors that were not specified in 2460, but in updating documents. So that was updated because those changes were incorporated into 8200. Probably the most important one being the difference in the processing, in the requirement for processing the hop-by-hop options extension header, which in 2460, it said that it was required for all nodes to process them, whereas in 8200, essentially says that they may process them. Like if you have a reason, if you have been explicitly configured to process them, you can, but it's not that you are required. And the other thing is, I mean, this was already noted in the abstract or introduction as far as I remember, but we added an applicability statement with notes that the advice is for transit routers for packets that have not been directed explicitly to them. So if you have one of those routers, we are not advising what to do for packets that are sent to your router, but for traffic that is going through. Next slide. So comments. I mean, the changes from the last previous version were minor. So I guess in any case, there should be, let's say, reviews to see if what we have in the document is okay, and run.
Be very close to it.
Take it.
Up here.
Ah, there it is.
Now
Okay.
it's on.
Hello. Ah, much better. A couple things we probably should do before we ship it again.
Uh-huh.
One is to make a distinction about which transit router these recommendations are for. One inside an ISP or one at a customer edge. Another possibility is, well, actually, that's the big one. That's the one that came off the mailing list, and we probably need to spend some time on that.
Uh-huh.
And one other possibility is at the last NANOG, there was a very large conversation about fragmentation headers. We probably want to see how that lands before we publish this.
Yeah, well, we talked a little bit about that. My take, and based on the, the discussion that we have had on the topic, is that this is kind of like trying to, let's say, blacklist those extension headers that, let's say, are known to be troublesome. I would agree that in practice, you might probably be dropping other stuff. Yeah.
Hi, Bob Hinded. So first of all, I agree with what Ron said. But I think this also needs to get some review, if not a last call in 6-man, because this is in some ways changing. I mean, 6-man just went through a big review of extension headers with what led to RFC 8200, and sort of updated it to what we thought the way extension headers should be handled. And so this is sort of saying something slightly different. I also think there's issues like, I don't see there's a lot of value in talking about what current implementations do, because they do whatever they do. And I think it just should focus on what we want to have happen. So I think this needs some more work. I don't think it's ready to advance.
What do you mean about the document talking about what current implementations are doing?
Well, I mean, the document talks about, uses the term legacy IPv6 pointing to 2460. And, a new RFC can't change running code. It's always going to be new stuff or updated stuff that might do something different.
See, what we tried to do here is actually cover both scenarios. Even before the publication of 8200, you already had like implementations that were already implementing what is now in 8200. So it was possible in some of them, not all of them, to actually, if you didn't want to, not process the hop by hop option. So essentially the only thing that we actually changed it in that respect was that before the publication of 8200, we were kind of like referring to that behavior as non-compliant behavior, because 2460 didn't allow that. But that was already there. There was already boxes that were not processing hop by hop options. So what we now did, the change that we did in this respect, is saying, well, now this is within 8200. And also what we keep is not just the behavior in 8200, but we also reference the one in 2460, because those boxes are going to be around anyway for, I don't know for how long.
Right, but you can't change what they do, because they're, like my laptop is doing whatever it's doing, or a router is doing what it's doing. We can say what we want things to do in the future, or this is a good policy to implement, but
Could I take a shot at
yeah.
responding?
Well, what we try to do is both, actually. We say what we'd like them to do, but for example, if you have a case where you have an router implementation that does the 2460 behavior, that tries, let's say, to process all the hop by hop options, and in that case, that means that the packet is being processed in the slow path. What we say is that in that case, you might want to, let's say, not process it at all, or drop it, or whatever that is.
I mean, but it says all that in 8200. So what's the value in saying it again?
If I could take it?
Yes. Go ahead.
Okay, this is one of the areas where we could use a little refinement. It may well be, it may well be that there is a router with these extension header filters, and behind it is a legacy device that doesn't have the 8200 hop-by-hop behavior. It has the 2460 behavior. What's worse, it might not even be able to filter hop-by-hop extensions. So for that purpose, it might be a good idea for, say, a transit router that's a CE to drop packets with hop-by-hops. Maybe, maybe not. But the thing is, it's only in some very specific conditions, and that's what we have to work out in the draft. When does it make sense? When is it because you're protecting a device behind you that can't protect itself? Or if you assume all the devices behind you are 8200 compliant, then pass it, let the device behind you protect itself.
Okay, so we expect a new version in the coming days or weeks.
Get like volunteers for review, or should we ask that for them on the mailing list? If there's like, because we did some changes, and if there's like new people particular that they can look at the document, that would be interesting. Let's say if they spot something that the previous guys that reviewed the document didn't.
But you received comment today, right?
Sorry?
You received comment today, so they should be incorporated to the next.
No, the comments that we received so far, they have been incorporated. So what we like is that for folks that did the comments, they review if the changes that we applied actually, address the issues that they raised, because maybe we didn't do a good job. And on the other hand, to have like folks that maybe didn't look at the document, to look at the document, because they might spot stuff that, so far other people didn't.
Okay. Eric?
Eric Klein. The thing that always comes to mind when I read these kind of documents is, how do we ever ship a new option? How do we ever ship anything new?
Just a comment. This document is extremely permissive. So among other things, says that it only blacklists, for example, routing header type 0, if you can do that. But it doesn't say that you should block stuff, for example, that you don't understand. So it's in line with 7045.
So if we had an IPv6 header option greasing kind of thing going on, like TLS greasing.
Sorry?
If we had a TLS If we had I have to modulate my volume here. If we had an IPv6 extension header greasing experiment going on, that would be okay and permitted by this document?
As far as I remember, I think that for the experimental options, I think the advice was to drop.
The devices are up. Right?
I think, but that's, again, it's within 7045. So that's what essentially, what we're applying here is what 7045 says. So Brian might correct me if I'm wrong.
Yeah. So one of the things that I know they're doing in TLS now is to just sort of include undefined options, but they're well formed with TLVs that are correct, so that if you just ignore them and skip them, the rest of everything parses correctly.
Okay.
There's a thing called, it's called greasing, and it actually is an acronym that means, I can't remember what it means. And in the sort of certificate format for TLS, everything is sort of well-formed TLVs. And if you don't know something, you can skip it, right? But there are certain problems where, due to ossification, general ossification of the internet, right? You can't add new certificate options unless you without breaking things. So they're experimentally adding things that are undefined, just to sort of deliberately provoke brokenness and provoke correct behavior. I wonder if we should have such a thing for extension options.
What off the top of my head, what I remember is, like, for unknown extension headers, unknown options, we don't recommend anything to drop. So it's like, in that case, no problem at all.
The only the queue, by the way, after Elliot.
What you write about experimental options, what we did, but Brian might correct me, is to do what 7045 was saying. So it's in line with that. So just a clarification. The fact that the document is called blah, blah, blah filtering is not that we are saying, it's not the whitelisted document, but it's the other way around. It permits a lot of stuff, everything essentially, except the stuff that is known to be bad.
Thank you.
Yeah, I think the language is, this is Brian Carpenter, I think the language is basically aligned with 7045 and therefore should be aligned with 8200, since those two are supposed to be aligned. But the devil's in the details, and I agree with Bob that I think Sixman needs to have a look. The other thing I wanted to comment on is, although at the beginning of the document it's scoped clearly for transit routers, and as Ron has suggested, perhaps you should even scope it more narrowly for different classes of transit routers. right? But in the text of recommendations that says, the advice chapter, you don't talk about routers, you talk about intermediate systems, which is a very, very general term in IPv6 land. So I think it would be actually just a language change, but a useful one too. When you mean transit router in the advice, just remind the reader each time it's a transit router you're talking about. It's not any arbitrary intermediate system anywhere in the IPv6 internet. It's specifically aimed at, scoped for transit routers.
That's a good point, and I agree with that. Yeah.
Lee Howard. I wanted to respond to Eric. From my reading of the draft right now, it says, section 4.4, packets with unknown v6 options specifically defines unknown as not being in the IANA registry. So greasing, and then it says, well, we can't do a security assessment of unknown options because they haven't been defined yet. I mean, it literally says, for obvious reasons, it's impossible to determine specific security implications of unknown v6 options. 4.4.4, discarding unknown IPv6 options may slow down the deployment of new IPv6 options. Exactly your point. As noted, the corresponding IANA registry should be monitored such that v6 option filtering rules are updated as new v6 options are standardized. So as I read that, it addresses the point. It says greasing would not work. It says once an option is defined meaning in the IANA registry, so it's been through the process, then we can talk about what you do with it, but shouldn't discard automatically.
No, this document doesn't say that you should drop packets with unknown extension headers or unknown options. So if there's a new option that is not in the IANA registry or that you define a new one, it will go through. It doesn't block stuff that is not yet defined.
Right.
So it's not that it's a whitelisting document, if you want. It's a blacklisting one, okay? Good.
So Eric Veng this time as a contributor with me, Ricky here, and KK somewhere, I guess, in San Jose or San Francisco. So update on this document, as I said in the introduction, it's version 12. So we spent years on this. We got a couple of comments in April, and again, a couple of them in July. I tried in the version 12 to address most of them, but not fully done yet. So next. So thanks, Eric, Toby, and maybe others. We changed a few things related. The text was basically based on the consensus dated 6 years ago. And for instance, at the last line, we say, dual stack is a preferred method for transition, while I'm pretty sure right now it's not the preferred method. We can go directly to IPv6 only, for instance, which is more common. So we remove the most preferred. We get it, I think it was Fernando draft, the 8060 with stable address identifier as the preferred way to handle privacy address. In some case, Eric Klein was clear the text around the usage of ULA was not negative enough. Right? My reading was negative, but Eric did not like it. So I made it more negative. Send, for instance, which was 6 years ago, may be useful, is basically now no more useful at all. So we put at the end of the text and something like that. So and then /64 per host, we put a couple of lines there as well. That's the change. We still need to do more stuff. And to be honest, the three authors, we are a little bit tired of this document. We cannot read it with a fresh eye anymore. So next slide. We need fresh blood. Okay, so we make some inspection among the friends and the security people that knows about IPv6 and that want be ready to help us with an operator background as well. And we found a German guy called Enoray, which is very, very brilliant. He knows a lot about IPv6 and security. So he accepted to be a co-author and will be refreshing it. That's the only way forward. And you know him, right? He's really good. Now we are still open, of course, for other people coming here. The goal is basically to review everything, fix a couple of errors, and address the remaining comment. I mean, the three authors are, I would say briefly, we are fed up with this document, right? We like it so much, but we spend so many time that we cannot do, like, don't have enough energy there. Okay, Meriki does not agree so much.
Medica Ko, Farside Security. from my perspective, I just had different priorities in life at this point in time. And so while I still care about the document, I keep making promises to the other co-authors, and I keep lying to them about creating an issue tracker and then actually having all the issues in Git, right, to address all of the comments that we received 3 months ago. Because when we then put it out to last call, I privately had tapped into a bunch of IPv6 operational folks who sent a slew of comments that were really good, but then actually looking through them, figuring out consensus, and then updating the document, it's something that all of us 3 authors really haven't had time commitments for. And so we finally have decided that we probably would like to have a 4th co-author. I know Enno quite well also, so when Eric mentioned his name, I was hands down for that. But the question that I have for the group, especially those that have had provided comments, I do have a question in terms of whether or not the issue tracker is the best way, like in Git, to actually get to consensus on probably 5, 10, 15 comments that we've had. Because part of the issue is that as the years go by, some older discussions get resurrected. And that's a pain in the ass. Right, and so, sorry for the French, but it is one of these frustrating aspects of actually getting a document to conclusion. And this one's quite interesting because every new year there's some new security nuance, right? So when do you even declare done? So any comments regarding on, whether or not we should be using the Git issue tracker to actually get closure to issues? Especially ones that, some people feel might still be open for discussion, I'd like to be aware of.
Sure.
Might be worthwhile to also ask it on the list, actually, the same question, if you want.
Okay. We tried. Oh.
Hey, just one comment, Eric, this is Elliot, on the discussion of ULAs in the document. There's one missing use case, or so it seems, for ULAs, which is where you have no internet connectivity and plan to have no internet connectivity. So that it really isn't a firewall issue there, right? It's just that, that was one of the use cases.
Yeah, that's an air gap issue then.
Brian Carpenter. Firstly, Bob didn't say it, but I think this one also needs to go to 6-man and probably V6 ops, before it goes to the IESG.
And just to interrupt you there, we made the working group last call was extended to 6-man and V6 up as well.
Yeah, I seem to remember that. The other thing is, I'll be writing to you about the ULA, but there's several things in that section that I think are not quite right yet. But also remember, there is a whole draft in 6-man floating around on the ULA scenarios.
Yeah, and it's referred.
You should give a reference to it.
It is referred.
Ron Bonica, Juniper. And in case a draft in 6-man isn't enough, there's another in V6 ops.
Thank you.
Right, good afternoon. My name is Elliot Lear. I work at Cisco, and I'm working on something involving IoT security that the chairs thought might be useful for me to talk about here. I see that Warren's in the room here. This document just went past Warren, and my goal actually is to address IoT security from the network perspective. Next slide, please. Next slide, please. Okay, the obligatory blah, 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 25 billion. Basically, we know we have a big problem, right? It's really, really big. It's going to get bigger. Somebody says 25 billion. Somebody else says 30 billion. Pick your billion number, put it here, and it's, I think in old-fashioned terms, we call this big num. Okay, next slide, please. This is not really my problem, actually, the 25, 30 billion, whatever. The problem is we don't know how to enumerate even the number of types of devices that are going to attach to the network. We can't even define what a type of a device is. Thus, we must once more rely on big num. Next slide, please. Within the axis of problems that we're addressing, The other thing is we're dealing with a multitude of environments. Anytime we talk about a thing, right, it could be anything from a one-time use device that gets dropped into a lake, which is intended to survive for 8 minutes or something like that, versus something that is meant to be dropped into a ground and meant to survive for 40 years. And so in that latter case there on the right, you can do your configuration and amortize it over, well, 40 years. On the other hand, if you're in like the medical industry, for instance, and you're using a device, the patient needs what the patient needs, when the patient needs it, and you don't get to amortize anything. In fact, if it doesn't work, people are going to go frantic, and possibly somebody might be injured or otherwise have a problem. Next slide, please. So what we're looking for, given the broad scope of devices that can be attacked and are attacked, circa Mirai and things like that, is to try and limit the threat surface of the device at the network level. And to put it in network terms, right, you got Bob and Alice, they're having a nice conversation. All of a sudden somebody, say Bob turns out to be evil, and you want to avoid the situation where Alice doesn't even have the opportunity to scream. Right, so that's the big challenge that we face in IoT devices. It's a classic vulnerability scenario, only the scale of it is incredibly large. So we're looking basically for two things for the device. The first of all is for it to protect itself. Now you would say, well, this is obvious, right? The device should protect itself. The problem is that while you and I and people in this room are in the computing and networking domain, we've been in it domain probably for a good long while. I know I have, and probably you have too. The people who are connecting transceivers to devices are really excellent in their domains, right? But it's not our domain. And so they're just learning all the things that can possibly go wrong in a security scenario, and they're going to get it wrong. See, for example, Mirai. And some of them might not care that much. See, for example, Mirai. But hopefully some will. And so we're asking basically, first of all, we're going to try and come up with some best practices, at least in my context, for these devices, right? You can't do this just through network controls, right? But you absolutely want the device to protect itself. On the other hand, defensive layer strategy says, well, let's find a way for the network to help. For this purpose, especially in an enterprise environment, which is where I started, and I know other people are looking in the consumer environment as well, we basically want the device to say, hey, here's what I am. Here's the communications that I need. Please protect me and limit access to me for only those purposes in an abstract way. Next slide, please. So I'm going to run through this really, really quickly because I know we don't have a lot of time. Basically, the assumption here is that in the context of IoT, Internet of Threats, a thing is a single is a device that has a single or small number of uses. And so we're not talking about general purpose computers here. We're talking about things with limited purpose. And for purposes of this discussion, let's assume that we're talking about things that are relatively tightly constrained. And that even the things that can protect themselves today probably won't be able to protect themselves tomorrow. And we can have that discussion at the bar for a very long time, and I'll get very drunk. And the other thing we'll make the assumption on, or at least the assertion on, is that network administrators get the final say as to how to protect their networks. What I'm going to talk about is more about configuring the network than about configuring the thing, so that seems fair. The result of all this is that because the thing has a single small number of uses, well, we can enumerate those. That's a very nice feature. That's a very nice engineering constraint, right? All of a sudden, if you can enumerate something and it's a small set, ooh, that's something you can really work with. And then, therefore, if these uses can be clearly identified, especially by those who have designed the device, since it has only a single small number of uses, right? Then you're in a very good position, and it reminds you about like a bottle of aspirin, where you get an indicator label, and if you want to go off label because you're the network administrator, so be it, right? And so next slide, please. All right, so what does this translate into in network terms? Very basically, access lists, right? We say, well, this is new technology. Not, right? It's been around since, I started in this organization when, Bob Hinden was young. And so So this is good, right? Because mature technology. Sorry, Bob. I'm having fun up here. Okay. The good news about mature technology, right, is that it's easy to integrate into new solutions. So next slide, please. So the basic concept here is the device is going to emit a URL, also not new technology, right? Using DHCP or LLDP or 802.1x with an AR certificate, also not new technology. Get that over essentially to what I call a MUD controller. The solution is called Manufacturer Usage Descriptions. The acronym is MUD, which means my marketing people hate me. That thing essentially is a AAA server. And it says, aha, URL, what will I do with this? So it goes and retrieves a file, right? The file is a Yang-based JSON file. Next slide, please. So that's the URL. Next slide, please. That looks sort of like this. We're changing it a little bit based on last call comments, which is basically an access list. And the idea is to abstract out IP addresses, so you have to fill in certain class information on this, or if you can, get it automatically filled in some cases, so that devices can then just talk to the things that they want to talk to. So the manufacturer is providing this file into the deployment. The deployment gets to fill this out, and all of a sudden you've just narrowed the scope of control in terms of who can attack the device. Next slide, please. So here are some of the abstractions that we have to play with. Same manufacturer, let me talk to things that were built by the same manufacturer. In some cases, just manufacturer, let me talk to things that are built by a particular manufacturer. And the manufacturer in this context is basically the authority section of a URL, so you can create arbitrary numbers of manufacturers. My controller, and this is more the simpler case where, if you've got a heater, for instance, it wants to talk to its thermostat, then maybe it has a list of thermostats that it is willing to talk to, and it can list those in a MUD file. Local means don't let the traffic get out for some value of local. And then DNS-based ACLs. Yes, welcome to 2017. ACLs really need to be sort of DNS-based. So those are the sort of capabilities that we're introducing. Next slide, please. And so all that basically goes back into the MUD controller. MUD controller installs it into some sort of access switch or something else that can do access control. And you have yourself a party. And by that, I mean, if you have a light bulb there, it's going to talk to a light switch. It's not going to talk to Amazon.com probably. Okay, next slide, please. Next slide, please. I'm going to skip the marketing stuff. So there's a little tension that we always have in the IETF between permissionless innovation and Wild Wild West. And Andrew Sullivan talked about this in the IAB plenary a year ago. And the basic idea is to find a happy medium in which the intent of the users, the intent of the local network is taken into account. And those people get to make the decisions that are based on recommendations from the manufacturer. So that's the meeting of the minds. Network functions implement that intent, if you will. And this is essentially trying to balance that tug of war that we see that goes on. Next slide, please. So summary, what you get. A URI, it's new, it's nifty, huh? No. Use of DHCP or ETLS or LLDP to transport the URI. Retrieval of a MUD file using essentially HTTPS as FTP and not much more, but a secure version. And instantiation of class information into a router or a switch or a policy enforcement point in order to protect the device. So that's it in a nutshell. Next slide, please. So recently, right, the document has completed both working group last call and IETF last call. We have a bunch of changes to make. We're trying to address privacy considerations as best we can with MUD, but I'll point out that the extreme privacy consideration here is we're trying to keep the device from being attacked. If it's hacked, then you can guarantee you have no privacy, at least as far as that device is concerned, because I see some people ready to just drive to the mic on this. But we have been working with Adrian and others to try and at least improve that text as best we can. We have a bunch of other issues that we've addressed, terminology, editorial, some clarity around HTTPS processing that Mark Nottingham is helping me with. He's also helping me with making sure the URL actually looks good. We're going to have a new draft. Probably, Warren, I'll probably need to send some new drafts, a new draft out on this once I've talked to you and a few other people and the Ops Area Working Group. So we have one normative dependency issue, which is driving me a little batty. which is that we're in an infinite loop, or I should say the ACL model is in an infinite loop, the ACL model is in an infinite loop, the ACL model is, well, anyway. So, and I'm trying to work with the people, it's gone through last call after last call after last call. We're trying to work through the issues relating to that, because why build a new model when you can use an existing model, which is what I started with and hoping what I'll finish with, but they have a couple of issues that they need to resolve over in NetMod. Ron.
Ron Bonica, Juniper Networks. First, I'd like to compliment it. It's a really good idea. The one comment I've got is it makes some assumptions about there being minimum capabilities for a device to be able to apply ACLs. Your MUD device may suggest an ACL that says something like, oh, if you see such and such a destination option, don't let it through. It may be that the device doing it can't do that.
Right. So the model that we're using is the IETF ACL model, and we're using even a constrained version of that. So you know, your typical where this gets implemented is in access switches, routers, and such. It's targeted towards those capabilities. But MUD has an extensibility mechanism to target other things if people want to go there. I'm just not going there now.
Fernando Gont,
Hi.
question. I mean, the idea is good, but I have like a question, which is, why did you decide to pull the policy from the vendor as opposed from the device?
Because the device might not have room to actually store the policy.
That's a good point. Let's say the drawback could be like, what if somehow the vendor got evil, got hacked or whatever? Like now all the devices will be pulling a policy from the vendor and networks could get open.
So yes, you're right. That's one vector of attack. Let me talk a little bit about that. The first of which is one of the things we're out for is if what we have is a URL that's in a certificate that is signed, it's not the device actually making an assertion about what it wants, but it's the vendor of the device making that assertion. And that's very important because more likely, the bigger likelihood here is that the device itself is going to get hacked, not some web server. We know how to protect web servers. And that web server itself uses a file that is itself signed, again by the vendor. So you have double protection on that front.
I'm saying it would happen, but I said like you could have like two different scenarios. One in which the vendor gets hacked, and the other one is that, let's say because of the recent events that we hear, that let's say that if somebody were to intervene with the vendor in the hopes of actually opening all of the networks that have these devices. And the other thing I'm not saying I guess it's a trade-off. And the other one is
the queue. I see we've got time for more questions.
And the other one is that let's say that I'm dropping some IoT device on my network.
Mm-hmm.
If I get the device to pull the policies from the vendor, I'm somehow exposing my device, like telling the vendor where I have one of those devices in my network, which I might not want to.
Okay, so first of all, it is not the device that pulls the policy. It is your infrastructure that will pull the policy and decide whether or not you want to implement it. So you can choose not to pull the policy.
Okay.
Right? So it's entirely up to you as to whether or not you want to use these functions. Furthermore, once you get the policy, you get to review the policy. I doubt people are going to blindly install policy into their routers, right? And then you can decide, you want to use it, not want to use it. At that point, it's totally up to you. It's your network.
Okay, cool.
Doug Montgomery Nest. I think it's good work. The MUD profile introduces some new concepts, right, to the standard ACL model. I wonder if you thought about, in particular, the same manufacturer semantic and how you would make that scale. I noticed you used a light bulb as your definitive canonical model there.
Mm-hmm.
Probably 1,000 or more light bulbs in my building. If my light bulb manufacturer pushed a MUD profile that said, same manufacturer, I think I have 1 million ACL rules.
Right. So there are a couple of things that you can do. And you're hitting a really good point, right? This is one of the scaling points. The first of all is first thing you can do is scope down, right, just how broad that you're going to allow same manufacturer to be. You can limit it to within a building. You could limit it to within some range. You can limit it to some number of devices. And you can also say, hey, wait a minute, this is going to impact more than N devices. I'm not installing this today. or you can say, hey, here's a recommended approach, use VLANs. You can allow for some manual processing. From Cisco's perspective, we'll probably do some things with TrustSec, for instance, to try and scale it. But the key thing, the key thing about MUD, right, is it talks about intent, right? So it says here's the intent, and it leaves in your local environment different means for you to implement that intent. So you could do it with, some people wanted to play some games with SDN. I know we have one particular partner who wants to play some games with SDN in that regard in terms of implementing intent. We've done some code that's available that uses radius and uses free radius actually to implement that intent. So there are a couple different ways you can implement the intent. The key thing here is to standardize the expression of intent between the manufacturer and your local deployment. How your local deployment implements that intent is entirely up to you.
Ron, the queue is closed already. Sorry.
One thing that we've thought of, right, is for that particular semantic, if you could bind it to a MAC prefix, I don't know
you could do that.
Who your collaborator is, but we're building an SDN implementation prototype. And if we could bind that to a MAC prefix, we could make that scale.
Right.
But the profile would have to tell us that all Xboxes share the following same MAC prefix.
Yeah, and you'd have to extend MUD because we don't go there, right? We don't do numbers inside of those for scaling reasons, but you could probably go there.
Something to think about.
Okay.
Eric, I'll add my voice to the chorus of people saying thank you for interesting work. I did have one quick question, and you don't have to go into too many details because I am ignorant of 802.1r, but the infrastructure pulls the certificate from the device?
The device, well, it's part of the authentication process in 802.1x. You need a certificate, and this is a manufacturer certificate to do the authentication. In an enterprise, right, you need a scalable way to onboard devices. So what's going on in other working groups is Anima and things like that in order to do that onboarding. So you have inventory inside an enterprise, so you know what's connecting to your network. And you need to know what's connecting to your network in order to, to classify what access those things need.
But if the device itself can be hacked, and then presumably the cert on the device can also be replaced?
As it's as easy or as hard as the protection of the cert inside that device.
So devices changing their certs probably needs to be audited or something.
I'm sorry?
Devices changing certs over time.
That's a longer term discussion. Yeah. Absolutely.
I see.
We should talk afterwards.
Thank you.
Thank you very much for the time.
Okay, thank you. Yep. So you have slightly less than 15 minutes.
Okay, so I'll try and adapt. This presentation is one that's been brought by Colin and me to the transport area primarily, but it's of interest to other areas, and that's kind of why we're doing the whole thing. I'm going to talk about a draft that describes the impact of transport header encryption on operation evolution of the internet. Let's go on. Next slide. Transports are designed to discover and adapt, and we're transport people, so that's what we want to do and make the internet a better place. And over the 30 years or so since transport people have been doing this, they've benefited from measurements and various insights from operators on how well these things work. So that's where we're at. Next slide. The world was once different to how it is now. Back in 1981, when TCP was defined, there was some notion of encryption above TCP. That came to be quite common. Now the world has changed so that encryption might become the norm. Most of the traffic flowing through the network could be encrypted in some form. The question is how much of it is encrypted and how many of the packets will look like this, where basically everything above the UDP header is just an encrypted blob. And does it matter? So moving on. Well, if some of it's like that, then nothing will break for sure, because it's been like that for a while with IPsec and VPNs and other things running in encrypted mode. But there's a growing amount of this traffic, and there's proposals to make a very large amount of the traffic like this. It would be good for many reasons, right? I mean, encryption can overcome ossification. You know, it can let things move faster. And we're actually seeing transport begin to change faster, which is quite unusual because transport typically runs quite slowly in its evolution cycle. But just go along to the meetings in ICCRG, etc., and you'll see things appearing in transport which we didn't think would happen, and are just now appearing, and people are saying they're deploying them. So things are starting to change, and maybe encryption will allow that to change faster. Maybe. There's good reasons for encryption apart from all this transport stuff. Protecting user privacy is good. Balancing out the control of who can change what and who has the authority to change things obviously has got real advantages. But what's the impact then if more of it's encrypted? Next slide. This slide was written for you. Why would operators want to look at transport headers? Next slide. Well, the first one's not particularly exciting. Volume, type of traffic. If you can see what the traffic is, you can start dissecting it and understanding what's going on. Quite important for some people in the operations area, particularly when you don't know what some large chunk of traffic is doing in your network, or you want to say, how is it behaving? Does it conform to the sort of compliance statement I have for the SLA? All of that gets quite difficult if everything's encrypted. People who play with IPsec networks realize this is kind of a difficult world if you don't have access to categorizing the traffic. Next one. Maybe transport people are more care about dynamics of traffic, understanding the scale of impact for new features. As features are introduced, you need to be able to measure what's going on. Transport headers actually give you a way to measure what's going on at the point where the change is having impact. Maybe if you have switches deploying some new queuing mechanisms, you can actually look at the packets going through, categorize the flows, look at the behavior of the protocol. So you can look at feature interactions. That might become more difficult if everything is encrypted. So there's some trade-off here. Next slide. The protocol interactions, looking in more detail about how these protocol mechanisms work, trying to identify whether a new mechanism is being used on a network, trying to identify what combination of network level features are used with what transport level features. Well, traditionally, we've done this using measurement files by putting in probes, by looking at traffic. And usually, operators are keen to make their services as good as they can. If users ask for help, then they're often willing to work with them to make sure that they keep their custom. If you can't tell what the traffic is, then the operator is going to say, oh, you've got this many packets through your network, it's still working. Which isn't quite the level of detail they could offer if they could say, looks like your TCP is behaving oddly, or your DNS isn't working, or whatever. So encryption's got some challenges ahead. The purpose of our draft isn't really to talk about the motivations of this. It's more, I think, to look back and say, well, over 30 years we've done all this. What's the stuff that we'll be losing if we suddenly change the way we operate? Can I look at the next slide? So, can pervasive encryption impede research and development of internet technology? Can it impede the standards process? I mean, it can have advantages. What are the disadvantages? Next slide. Designing transport protocols isn't that easy. It's possible to get things wrong. It's possible to design applications that kind of mess up other applications that share the internet. And next slide. Measurements are needed. Where do we get the measurement data from? Well, we could get it from endpoints. There's a trust relationship here. If you actually trust your content provider to provide all the statistics about their traffic, that's a bit kind of difficult to know the incentives for them to provide you with the right information. And it's certainly not a good idea to allow monitoring of all the edge devices to monitor the traffic that goes there. So if traffic monitoring has to be based on measurements, and measuring characteristics will have to be done in the network, then you have to give the network at least enough information to operate upon. Go on, next slide. And one of the key points that we've had in the internet community has been, at least at the transport layer, is to try and make the internet work across many different types of network. And here, I think there's an interesting point to play out. If the world changes to a fully encrypted world where you don't see any headers, where you don't know what's using your network, where you have no idea about the scale of deployment of anything using that network, it might be very hard to know whether the mechanisms we've built and standardized here actually work for all networks. There's a reasonable diversity out there of different link speeds. It used to be we had an internet back in the days of the original TCP that worked up to megabits. I mean, that was unbelievably huge. Yeah? Now, 100 gigabits is possible, and we want a network technology that scales over all these different types of network. We have networks with delays sub-millisecond. We have networks with delays, someone presenting ICCRG with over a second of delay. We have a very wide variety of networks, a very large variety of underlying infrastructures in terms of the way we get the bandwidth and capacity. How do we make sure all of this fits together? Well, I think helping to do that would be good measurements. That's the way we've run to date. And the IETF procedure has usually looked at that broadness through things like the ICCRG research group. Next slide. So trying to be really quick. How does the IETF provide incentives to ensure good practice that benefits the wide diversity of requirements for the internet community as a whole? The encryption piece plays into this space, and we want help to try and understand whether the piece that we've written here actually heads in that direction. Version 4 of the document has been re-edited and restructured so that you can read the different arguments, and we'd love input. Useful input, preferably, but input of any type. Go ahead.
So we have basically 5 minutes for all the questions and the answer, of course.
Okay, thanks. Hi, Nalini Elkins. This is great. We actually, as a group of large enterprises who run data centers, are very, very interested in this. And in fact, we've been coming up with a bunch of requirements. And we would actually like to see inside the payload as well for many, many reasons. But definitely looking at the transport header, helps us solve any number of problems because you can't really scale your networks up to a certain point. I mean, before you really, before the performance problems, all that kind of stuff really gets, to be such a big issue, and the transport layer is very important. So thank you for doing this work, and would love to talk to you and work with you.
Yeah, please talk. Thank you.
Fleming Andreas, echoing a lot of the comments. I think this is great work. I think we need more awareness of these issues. It seems like there's a lot of focus, and for good reason, of course, around privacy and end-to-end security, but we're forgetting some things in the process. And I think we need to have a more balanced view. The operational considerations that you're bringing up here is one of them. There are others, as Nalini was bringing up. In the security space, I mean, we have some concerns as well, but it is a trade-off, of course. So thank you for doing the work, and hopefully we can find a way of progressing it.
Okay, thank you.
Hi, Chris Morrow, Google. So mostly this seems interesting, although I think a lot of the problems that you're sort of linking to are tooling problems, right? Like, I can't see inside the payloads. I don't know what this is. Well, it's not really true. There are lots of behavioral analysis you can do for the traffic. It'll tell you.
Yeah, the draft
exactly
says that. Yeah.
Right.
Yeah.
So I think maybe some of the problem is the world is changing and the tooling has to change. And so how do we change the tooling? Is that really what you're trying to get at? Which would be great.
I don't know. What I wanted to see is a balance between the two views, so we can actually work out what actually we're losing, what actually we're gaining, how we can do new stuff.
Yeah,
so maybe part of that, yeah.
Okay, I guess it seems like there's at least 3 or 4 different conversations about this exact same topic in the IETF.
There is.
And they really seem a lot like we just need better tools instead of we can't encrypt stuff, because I don't know. I think encrypting is actually a good idea. But anyway, thanks.
Thank you. Oops. Oh, the mic's bounced. That's good.
I'm not going to put that up. So Warren Kamari, just want to say this is good work, and also use this a little bit as a soapbox to mention a related draft, the effects of pervasive encryption on operators, which you do reference a number of times. The soapbox bit is, everyone, this is an IETF last call. It had a very entertaining last call last time, and would be very useful if people can read it and comment, etc. It's very closely related to this. It's largely, more encryption makes operators' lives change. Not necessarily don't do it, just different.
Yeah, that particular draft does deserve comments because it's very much an operator perspective on boxes and methods that are currently in use.
Hi, Igor Vyshinsky, Yahoo, Oath, Verizon, whatever. I'm a bit confused as to what the purpose of this draft is, because it seems like we're encrypting more, so you can't see as much. Duh.
Yeah, that's it. But in the IETF, maybe we've done that process and people haven't thought about how we operated up to the point where that encryption takes place and what actually we were using those headers for other purposes than the end-to-end communication. So, I mean, does it hurt to expose an RTT measurement? Does it hurt to expose a packet sequence number? How much pain is there in exposing something to do with connection ID? I mean, these are things which, if you took a pure security model for, you would encrypt everything because you don't know what the risk is. Right. But if there are merits for exposing some of that information, maybe the IETF would be better exposing some of this information so that other people in the IETF can do other things with these headers because that's part of the general community.
So is the goal of this draft to enumerate everything that all of this unencrypted headers are used for and then suggest what should or should not be kept, or just enumerate, or just talk about stuff that is being done? Because again, like what Chris is saying, a lot of the data that is currently unencrypted that may become encrypted, some sort of frequency analysis will get you enough. Or you could fast forward to a world where everything is wrapped in QUIC and maybe not.
Yeah, I think if you go forward to encrypting everything above the UDP layer, you will lose some functionality. And I really want to understand what those bits are so that we make a conscious decision. If we want to go that way, we do that with good reason.
Okay, so which thing are you trying, is this draft supposed to do?
I think we need to start wrapping up, actually.
This is something we can talk about. I'll happily take comments. Colin's over here as well, co-author. Let's talk. But we don't intend to be biased. We would love to have both views expressed and go forward on this, and just not lose our history.
The remaining of the discussion after the session, because we're out of time, really. We're like 20 minutes,
So next session is to relate it vaguely to the same topic.
Yeah, how much time do I have? 7 minutes, great, okay. Afternoon, everyone. My name is Chris Wood. I'm a software engineer at Apple, and I'll be talking to you about our draft, which is on separating encrypted negotiation and communication. This is also something that emerged in the TAPS working group. Next slide, please. To give you a little bit of background, part of the charter of the TAPS working group is to identify some minimum set of requirements that transport services should provide to applications, and until recently, things that were related to security were kind of omitted from that particular set, or that minimum set, and we wanted to go out and actually see what particular security services should be offered by modern transport security protocols, and kind of in that same vein, we also started realizing that certain features of transport security protocols are becoming more and more common, like session resumption, and things like session resumption can happen on different connections than the original. For example, you can resume a connection on a different connection than when you on the one you originally received the ticket, or in TLS case, a particular ticket. Long story short, you don't need to use the same transport connection for all of your crypto needs. You can obtain key material and tickets on one connection and use this key material and crypto on a different connection. I wanted to kind of see if we could separate these out. And in doing so, this led to a more grand vision in which we kind of decomposed transport security protocols into 3 constituent modules, or bits and pieces. That is the transport piece, which is actually responsible for sending data over the wire. The handshake piece, which is actually responsible for doing crypto negotiation, and the record piece, which is responsible for framing and encrypting data before it's sent out in the wire. Next slide, please. And so this is exactly how we define these 3 things. Next slide. And they're related in various ways depending on which particular protocol you're using. So like TLS, for example, kind of lumps together the handshake and the record protocol into the same spec. Things like Quick kind of decouple the two, or the IETF Quick, where you have one particular draft that defines how you do like a handshake with TLS, and another draft that defines how you would do the transport bits of Quick using key material that you get from TLS. Next slide, please. And so each of these different pieces are, like I said, responsible for unique features or unique services that are provided by these transport security protocols. So like the handshake one, like I kind of enumerated already, is responsible for things like authenticating an endpoint, doing source address validation in a DTLS world, and doing an actual key exchange. Next slide, please. The record protocol, or the record module, is responsible for actually encrypting data. Next slide. And the transport one is basically about moving bits over the wire. And we point to this particular RFC, which is basically an enumeration of all the existing IETF transport protocols and the services they provide, like congestion control and multiplexing and so on and so forth. Next slide. So a part of the draft goes through and enumerates existing transport security protocols and how you can decompose them into the various constituent pieces, like the handshake, record, and transport, as a way of kind of making the case that potentially crypto negotiation should be separated from the actual transport communication layer. And so in TLS's case, for example, I was kind of saying earlier that by the specification, the handshake and actual encryption bits are kind of lumped together. Here you can kind of you can decouple them accordingly. Like the record layer, for example, can just suck in like a pre-shared key or a ticket and then just start sending data over to a particular endpoint using some TCP socket or TCP connection you've established accordingly. Or if you're establishing a fresh connection, you would actually use the handshake bit to derive a shared secret with the other endpoint. Next slide, please. Quick is a bit different. Like I said, the drafts kind of keep these things much more decoupled. So there's like the actual main Quick draft, which is responsible for things like transport. There's a separate draft defining exactly how you would do handshake to derive the key material with TLS. And then there's that also kind of describes how you would do like packet protection and encrypting individual frames, Quick frames, using the secret that's derived from TLS. And all these things are kind of kept distinct. So you could, in theory, for example, swap in a different key exchange protocol instead of TLS and achieve the same output, provided that the security guarantees of that particular handshake protocol match that of TLS. That's to say, you have the same ability to authenticate the endpoint, you have the same ability to derive the same kind of secret, and so on and so forth. Next slide, please. And TCP crypt is another example, but these are pretty much, you can lump these all into the same particular bucket. The TCP layer is responsible for the key exchange, for the actual encryption, and for the actual transport itself, because it's just adding encryption right into TCP. Next slide, please. And then IETF2, ESP, not really a transport protocol per se, but you can kind of look at it in the same kind of decomposition lens, where you have IKE actually doing the handshake and deriving a secret that then you shove into ESP to actually encrypt datagrams between the two endpoints. And all of this is sent over an unreliable datagram transport channel, which is IP in this particular case. Next slide. So this seems to be a common pattern. I mean, you can look at many of these different protocols and clearly separate out the relevant pieces, the three relevant bits. And actually doing this in practice seems to have a number of different benefits. For example, you can reduce connection latency by out of band going and fetching like cryptographic key material, like a TLS session ticket, for example, and then using that later to resume your session without as many round trip times. I mean, you might imagine a setup where you have some daemon, for example, pre-fetching tickets and then actually, vending them to clients that want to use them for faster resumption. Saying that's a good idea, but it's like, in theory, you could do that and be fine. It also offers you protocol flexibility, where you can kind of, if you have a common interface for these bits and these particular modules, you could swap in different implementations and in theory have the same effect. So going back to the quick example, if we had a different non-TLS way to derive a shared secret that was IETF approved, you could just shove that into the handshake portion of the quick protocol and it would just work. You can also use this or exploit this particular separation to negotiate protocol capabilities out of band. So for example, you could probe an endpoint to see what particular protocols are offered. Like if you're using TLS, for example, you could learn that, oh, this particular endpoint supports quick by its ALPN value that it sends back. And then you could, upon resumption, start using quick or H2 or whatever to talk to that particular endpoint. So you can, learn things a priori to kind of help drive how you would use or use a connection to a particular different endpoint or that same endpoint at a different point in time. It also kind of leads to better or more modular software design. Of course, if you have these, decoupled components that are nicely separated, you can, and with a clean interface, you can mix and match them as needed instead of having kind of everything lumped together, like in the case of TLS. Next slide, please. So this is, kind of brand new work and still ongoing. One of the main goals we're trying to do right now is to integrate the module interfaces that we've identified here. That is the handshake, transport, and record interfaces into the TAPS min set. So like security is reflected as a service provided by a actual transport protocol. We want to actually go out and get complete coverage of all the popular secure transport protocols that are in use today. And we've looked at most of the major ones. I mean, the ones I've enumerated here, and things like minimal T, which are not actually IETF, but still relevant to transport security in general. And then the third one is probably most important. We need to actually have this reviewed by the security area, particularly because there's a lot of work that went into the analysis of TLS as a single complete protocol, and it requires delicate. You have to be very careful on how you compose these things to make sure that they're still safe. Like for example, just taking a record implementation and a key that you've established out of band and using them together. And in theory, it should work, but we need to be careful. I think that's it. Did I make the time?
Thank you for being fast and
Yeah.
concise. We have time to take one question maybe for Chris.
Works for me.
Looks like it was fast and clear.
Right.
Thank you.
Yep.
So if you can be brief between 10 and 15 minutes. If you can be brief.
Okay. Good evening. My name is Hiroyuki Baba from the University of Tokyo. I'd like to explain our ID problems in and among industries for the prompt realization of IoT and safety considerations. Next, please. This ID describes challenges to build up IoT society and consists of two part of themes. One is the problems in and among industries for the prompt realization of IoT, and another is safety considerations. Problems in this ID are results of our interview to both ICT industry and things industry. And the safety considerations comes from our study at the University of Tokyo. Next, please. Motivation for writing this ID is to prototyping an openly fileable document of barriers against building up IoT society. Next, please. Objective of our activity are what are challenges for realizing IoT, and what is safety issue in things world in IoT era. Next, please. Meeting for interview. We interviewed 10 companies in both ICT industry and things industry. Next, please. Skip. Yes. prevalent in and among industries for the prompt realization of IoT. Today, time for our presentation is limited, so I will show the highlights of our ID. Highlight one, information security. Suppose that connecting the entrance door to the network, increasing the key length of the encryption makes it much harder to break, but the information security technology will become obsolete and even pose a risk about halfway through the 20 to 30 years lifetime of the entrance door. So we'd like to say, if you use wrong key at the electronic key, but it's easy to break electronic key in 20 years. Next one, please. Privacy in acquiring data. Up till now, there has been a divided debate on whether the data belong to the company or to the users. But one specific example is of a company that had obtained permission from the head of the household to use the data when it carried out an HEMS trial. Later on, the spouse of the head of the household disagreed, and as a result, permission to use of the data was withdrawn. So in this case, who is the user? Next one, please. Traffic patterns. Questions such as how much traffic will come from what kind of things, and how will they superimpose each other have not been sufficiently studied. There is no concrete explanation about the backbone design and operation of traffic. And there have been many cases in which the unclear specifications for IoT traffic made the design difficult on the communication company side. Additionally, the configuration of IoT equipment with a large number of sensors involves a lot of hard work. Next, please. Item 4, the physically handling acquired data and data calibration. An even greater amount of effort will be needed to determine the meaning of the data and connect it to the physical world. And another important thing is calibration for correctly indicating for the operating conditions. So we'd like to say, how can we manage too much work, configuration, and determine the meaning of data and calibration on all of many IoT devices, such as the sensors and etc. Next one, please. Highlight 5, product lifetime. The life of most ICT equipment is about 5 years or less, while the life of IoT equipment and devices is at least 10 years. In the example of the entrance door is connected to the network, the communication technology and the communication service will most likely have undergone numerous generation changes in that 20 to 30 years time span of door. So ICT in the ICT field, the lifetime is almost under 5 years, versus in the things world, lifetime is 20 or 30 years. This is a large gap of lifetime of between ICT and things world. Next one, please. Number 6, fault isolation. If users are left to isolate the fault on their own, they have not know which manufacturer they contact for repairs. If they are unable to isolate the fault on their own, or manufacturer may refuse to perform repairs because they fall outside the scope of their responsibility. So we'd like to say when the air conditioning is bad in home, the end user can't know which element of the system is out of order. Application, network, or air conditioner itself. Next one, please. Next, please. Yes. Using radio waves, we have interviewed 10 companies. So there are many cases that have provided us with insight about issues related to the use of radio waves in IoT. They often ask questions about how many meters radio wave can travel, or whether radio waves can actually travel. The lack of engineers who can advise on specialized matters such as these processes are a major obstacle. Next one, please. Next two is corporate management. Up till now, companies in things industry have developed products in a closed-loop process, seeking to capture users with their company-owned products. For this reason, the lack of open design concept will interoperability. Today, an entirely new design concept is needed to design product that can interconnect with the products of other companies. Next, please. And the ecosystems. In the IoT era, the traditional vertically integrated way of producing things is manufacturing industries will consume too much time and cost. This approach will make it difficult to incorporate the ideas of other cultures. The need for paradigm shift is easy to understand, but difficult to implement. Next, please. Safety considerations. I will briefly explain that. Next one, please. The challenge in protecting lives and property from IoT-related threats. We call that IoT safety. The introduction of IoT may generate a threat to safety through the actual operation of mechanical devices, in addition to the information security problems. Next, please. We write this chart. So, excuse me. We think in the IoT world, we need a countermeasure to keep both cybersecurity and safety. In this ID, safety means avoiding actual or physical threats of or from IoT devices. We call it IoT safety, and think IoT safety is different from cybersecurity. We show the 3 examples in our ID. Next one, please. Safety of body or life. The mischief application sensing the absence of a smart house with smart meters or something, and it unlock the command to the door keys and inform the thief to please invade the house. Next one, please. Next, please. Safety of equipment. Mischief application sends if the mischief application sends on, off, it's easy to break the appliance. Next one, please. Proper performance of equipment. Mischief application send command to heat water at 10% tank capacity. So, end users wondering why I cannot get hot water enough. Next one, please. And I will show the test bed at our university. Next, please. We have the experimental house in our campus named the Coma House. And the house is connected to the web API at the internet. So application vendors can get access to the real world via web API without study the special protocol to control the things. Next, please. We promote the open innovation scheme as follows. That's all for my presentation. Thank you.
Any questions or suggestions? If not, we have 6 minutes for the last. So maybe 7, right, if you can go a little bit further.
Thank you. So this is joint work with Doug Montgomery, who's here, and Jeff Haas. Can we jump to slide 7, please? So, so last time in Prague, we presented this enhanced feasible path URPF. And the idea was that, and this would work in certain scenarios. So the discussion we had in Prague was that it would work in certain scenarios, but there are some other challenging scenarios where it might not work. By work here, we mean that when you do URPF as a network operator, you want to be careful about not dropping data packets that come in with legitimate source addresses. And that could very well happen with the feasible path. I mean, it does happen with strict URPF, but it could also happen with feasible path URPF. So we proposed an enhancement which tries to overcome that. And that was explained through this example. And the basic idea here was that if I hear prefix P1 on my, I'm AS4 on top. I'm the network operator of AS4. On the interface on the left towards AS2, I have prefix P1 is what I get in a route, and I don't get P2 on that interface. So if I apply feasible path URPF, it's I mean the data from AS1. Which has prefixes P1, P2, P3. The data can come with source address in P2 or P3, and I might be dropping those packets and don't want to happen that to happen. So what is done here is that I look into my RIB and I figure it out that this originating AS that I see in this announcement on the left side, P1 with origin AS1. I look into the RIB and I figure out that with originating from that AS, I also have P2 and P3 routes for which I have heard on other interface, not the same interface on the left. So now I generalize my construction of the reverse path filter table, and I include P2 and P3 in the table on that interface on the left. So I make it more generalized, more flexible. And I do the same for all interface, and this works for certain scenarios. Next slide. And it was pointed out in the working group, the discussion list, as well as in the meeting, that there are scenarios like this which are challenging, even with that improvement on the feasible path. And what is challenging here is that on the left side now, AS1 uses no export, and as a result, AS2 does not propagate P1 and P2 to AS4. So in the proposal, AS4 depended on at least one prefix P1 or P2 to make it on that interface, have a route announced on that interface, but that's not happening now. So that's the challenge. In this case, that method doesn't work, but we have an enhancement which is explained on the next slide, please. So the algorithm now is that you consider the list of interfaces that you have towards customers, that is the set I, and you look at all the routes that you are receiving on those interfaces, and from those routes, you pick all the unique prefixes that you have heard. And also from those routes, you make a list of the ASS that are origin ASS in those routes. And so now you have, that. And then you make also a list of prefixes which you have heard or in routes from other interfaces, provider or peers. And and which have the same origin, I mean, which have origin AS as one of the ASs belonging in the list A. So which means that you have a picture of your customer cone, and some of your prefixes may be multi-homed, and they are only announced to your peer who is another ISP for your customer, and you are hearing that prefix through your peer. Can we go to the next slide? So just 2 minutes. Okay, great. Thank you. This adds more flexibility compared to what we already proposed before. And that additional flexibility is that I look at all my customer interfaces, I make the union of the prefixes that I see in the routes on the customer interfaces. And in addition to that, I also figure out from my peers what are the routes that I am hearing, in which I see the same origin ASS that are in my customer cone. And now I can combine those two lists, the prefixes that I hear on customer interfaces and the prefixes that I hear from a peer or a provider, which happen to have, those routes happen to have same ASS as origins that are already in my customer cone. So by combining those, I make a union of those prefixes and apply them in the reverse path filter list for each one of my customer interfaces. And that would then take care of the challenging scenario that we earlier presented, which is there on the left side, the no export situation. So this kind of addresses the problems or concerns that we had in Prague. And just one, next slide, please. The other concern that we had in Prague was, do we have enough, or how much additional burden is it going to impose on the RIB memory? And for that, we estimated the customer cone sizes for different ISPs, global, large global, mid-size, regional, etc. And what we see that is that the prefix ranges might be in the 30,000 to the 1,000 range. And the customer cone size equals the reverse path filter size. Next slide, please. So the reverse path filter size is the additional fib memory that you need in the line card in order to implement this URPF. And what we gather from product literature, that you can have large ISPs might have 2 million to 6 million, smaller ISPs might have only 100K. But no matter which, if you compare these numbers with the RPF filter size on the previous slide, the additional fib memory that you require is only on the order of 1%. So we are hoping that this analysis is good and it addresses the fib memory issue as well. So we welcome very much additional discussion on the list and welcome your feedback. And we are hoping that the next step might be to request a working group adoption call. After some discussion on the list. Okay. Okay, thank you.
We have time for one question, maybe. Even better. So, OPSEC meeting is adjourned. Enjoy your break. And thank you for all speakers coming presenting their draft.